All right. So the next kind of equation that you would be asked to solve would be a mole to mole. Mole to mole is going to be the most common probably, which is just like also grams to grams. It's going to be the most common one. It's pretty much the one you do the most. All right, so you're given 4.42 grams of C4H10, which is butane, and you want to find the mass that would make of CO2 in this reaction. So you start off with 4.42 grams C4H10. Okay, now you want to convert that into moles because you're going to need to do your mole ratio. Actually, hold on. Right, so we're 4.42 grams. C4H10. Okay, convert this to moles. You're going to have your mole on top. You're always going to have the same units here and here. So 1 mole C4H10. And then for every mole of butane, which is what that is, it's going to be 58.14 grams, which is just your molar mass. Okay, now you're going to set up your mole ratio. So because you want to find the mass of this, that's going to go on top. So 8 mole CO2 every 2 mole of butane. Okay. Now, that's where we ended on the last one. And all you do is just one more step. So for every 1 mole of CO2, you just find how many grams that is. Should be 44.01 grams. And then multiply across. You get 13.4 grams CO2. That's it. Now, you can also have equations that would ask for grams to liters, or liters to grams, mole to grams. If it starts in moles to liter, that's just one less step you have to do. If it's grams to liter, it's one more. So, all right. So in this one, you're given 20 grams of potassium, and you want to find how many liters that would produce of hydrogen. Remember, hydrogen's in your diatomic state, so it's going to be H2. Okay, so you're given 20.0 grams potassium. Convert that into moles. So 1 mole, okay, is going to be, be 39.10 grams. Now your mole ratio comes in. So for every 1 mole of hydrogen, you have 2 moles of potassium. So 1 mole H2, 2 mole, okay. And now, instead of doing like we did above with putting for every mole, you're still going to have mole as your denominator. So for every 1 mole of H2, instead of finding how many grams and finding your molar mass, you're just going to do, I mean, this is even easier because it's the same for everything, because 1 mole is always equal to 22.4 liters at standard temperature and pressure. So it's always going to be 22.4 over 1 mole. And then again, cross multiply across, just multiply through. It's going to give you 5.73 liters of H2. And that's that. And like I said, like if you were given the moles of, say, potassium, you would just cut this step out right here, and you would just have, say, how many moles that was, and then you would just skip right to mole ratio, and then converting it to liters. So it's just one less step you'd have to do. All right.